Sorry? I don't know. Xavier, is this the answer? No. Okay, what else do we need to do? Cannot hear you. If I cannot hear you, you can either say louder or you can come here. What about 5? Xavier, what do you say? Times. Times what? Times 15 again, huh? Do you change your mind? 40? Okay, correct. So this is the capacity of the tank, which is otherwise known as the volume. That gives us 15,000. So 15,000 cubic centimeters. So next is to find the volume of the water in the tank. So part A was the capacity of the tank. Capacity meaning how much it can you can pour it. Whereas in part B, they're asking about the volume of the water inside. So part B, volume of the water. So Javier, what do we do for part B? If you can do part A, you can do part B. It's the same type of question. 16 times 40 times 15. Very good. Did you learn something? 16, 40, and 15. So we get 9,600 cubic centimeters. This is the volume of the water in the tank. Okay, so we see that the volume of the water in the tank is actually less than the capacity, which makes sense. Next, question 5. So now we've got a tank in the shape of a cuboid again. In our syllabus so far, we've only dealt with cuboids. It is always length times breadth times height for the volume. Base area is given to be 100 square meters, this portion. 100 square meters. Let's ensure that we really understand what is happening over here. What are some possible values for the length and the breadth? I'm talking about possible values. I don't know the values, but what are some possible values? 40 and why you choose such a difficult number? 40 and 10. But 40 times 10 gives me 400, not 100. So no, not 40 and 10. 10 and 10 and 10. 10 and 10. Wait, 10 times 10. Yeah, we do get 100. But why you change your minds? I want 190. Oh, because the base is not a square. It's not a cube. The base is not a square, it's a rectangle. So what times what can yeah, okay. That's one possibility. 20 times 5. That gives us 100. That is one possibility. Not that it is the correct value. Okay, there are other values as well. So just now Jerry said 40, this would be 2.5. These are possible. Okay. I just want you to understand what they say, what they mean when they say the base is 100 square meters. I don't know the two values, but I know that when you multiply them together, you get 100. And they continue to tell us that it is filled with 950 cubic meters of water. The volume is 950. The base is 100. So that brings us to the unknown height. And yes, okay, Marilyn, can you help us with this? So we were saying that this tank has a base 100 square meters and its volume is 950 cubic meters. So we want to find the height. What is the relationship between the base, the height, and the volume? What is the relationship between these three items? Are they related? Does one thing affect the other? So let's start with that simpler question first. Marilyn, now if the value of H increase, visualize what's happening. If the value of H increase, what happens to the amount of water inside? More or less? Or same? Same. If you're saying that if this amount, this height go up, the amount of water is still the same? Is that what I'm saying? Yes? How does this height increase? No, I'm talking about the height of the water. So Marilyn, if the height of the water increase, does that mean that there is more water inside? Yes, it does. Yes, Brian, what's happening? Brian said you saying that the amount of water doesn't change, is it? I'm talking about the height of the water. The height of the water, this H. If it increases, it means that there is more water inside, isn't it? So Marilyn, if this H drops down, what happens to the amount of water inside? Decrease. Very good. So the amount of water is related to the value 950. So similarly, the base over here also affects the amount of water inside. Okay? If the base is very big, imagine I make the base very, very big, but the height remains the same. No, I fix the height don't change. If the base is very big, does it mean that there is more water inside? Think about it. It's like a swimming pool, you know? It's like a swimming pool. I make the base very, very big, but the height remains the same. It means there's a lot of water, isn't it? But if the base is very, very tiny, and then the height remains the same, it's kind of like a water bottle. Very little water. You have to understand that these are the things that affect the volume of water. That is why we have length times breadth times height, which gives us the volume. Okay? So what did I just say about the volume, Marilyn? What did I just say about the volume? What times what times what? I just said it like 1 minute ago only, or maybe less than that. How do you find the volume of the water over here? Later when Shah comes out, you'll be stunned already. Yeah, I guess so. Yes, Marilyn. What times what to give us the volume? I cannot hear you. Come here. You don't want to say loud enough, then you have to come here already. Yes, what do you say? Length times breadth times height. Very good. Wait. Length times breadth times height. Do you know the length over here? Is it given in the diagram? No, right? Do you know the breadth? Really? Why is the breadth 100? What is this 100 for? What about the base? Area. Okay, area is 100, but it didn't say the breadth is 100, right? Okay, what does length times breadth give us? What does length times breadth give us? Area. Okay, so how much is the area again? 100. What is the volume in this case? What is the volume in this question? It's given. Okay, so we put 950 over here, because that's the volume, right? Then this is the area, then multiply by H. Okay, so what is H? I want to find H. So what is H? What should we do now? Very good. Divide by what? Excellent. Divide by 100. Divide by 100. So she remembered her algebra. And when we do so, thank you very much. We can go back already. We get 9.5. That is our value of H. So swap it around. All right, H equals to 9.5 meters. So by doing so, you can check your answer. In your mind, just think, if H is 9.5, 100 times 9.5, it gives me 950 cubic meters. And that is correct. That is the volume that was given to us. So yes, Marilyn got it. A little challenging, but she managed to do it. Okay. Now next, question 6. Yeah. Now Mei Jing wants to pour all the water from a tank that is in the shape of a cuboid. So you can see that, oh, it is not completely filled. Into an empty tank that is in the shape of a cube. Will the water in the cube overflow? Will it overflow? So do you understand the question? Do you understand the scenario? Is the English okay? Human okay? Understand? Okay, so now let's not talk about maths. We just talk about logic only. Just logic. If you have to pour water from one container to another container, and we have to decide, is it going to overflow? What information do you need? Nazrin, what do you think? What information do you need to decide? You understand the question? Yeah, okay. So is it going to overflow or not? It depends on a few things. Say again? Yes, it is going to overflow. But how do you decide? The question is, how do you decide? Not, oh, it looks like it's too much water, so it will overflow. No. Okay, because maybe they didn't draw it properly. So, how to decide? No. I don't want to know calculation. I want to know the logic behind it. If I want to pour everything here into this container, pour everything, is it going to overflow? Why are you so sure? Bottle big, bottle small. What if I tell you this bottle is empty? Then when I pour, will it overflow? No, right? Okay, so what does it depend on? Does it depend on the shape? On the water, huh? Does it depend on the brand of water inside? What about the water? Say again. Amount of water. What is the keyword when we talk about amount of water? It starts with V, the letter V. The volume of the water inside, right? The volume of the water inside, if it is a lot, then it will overflow, is it? But shouldn't it depend on the capacity of this? Capacity meaning how much space this has. It depends on both, right? I need to know first how much water there is over here. Next, I need to know the capacity. How big is this? So these are the two things I need to know. Okay, so Nazrin, tell us what happens if the amount of water is more than the capacity. What will happen? Overflow, very good. What happens if the amount of water is less than the capacity? Amount of water less than capacity. What will happen if I pour? Will it overflow? No, it won't overflow. What if the amount of water is exactly the same as the volume over here, the capacity over here? What will happen? It'll be just nice, isn't it? So what are the two things I need to calculate now? Nazrin, what are the two things to calculate? What did you want to know? See, we're always comparing two things over here, right? What are the two things again? Go ask him, what are the two things? You went through the logic with me already. I'm sure you know. So what do you want to calculate from here? What is shaking head? Come here, come here, come here. Okay, let's use the anti. The ball. On the ball, all these inside, will it overflow? Yes or no? Or don't know? Yes, no, or don't know? How you so sure? How you know the capacity? No lah, you haven't calculated anything, right? No, never say capacity, or yeah, never say capacity. So what do we need to find out? Wait, what do we need to find out from here? You need to find out the capacity. Okay, this is our cube. We are going to pour the water from here into the cube. I need to know the capacity. So one thing, capacity equals to, that is what you need to know. What about the other thing that you need to know? Volume of what? Inside here, right? So I need to know the volume of water here. Equal question mark. So if I find out these two things, and this value is more than capacity, what will happen? Overflow. If this volume is less than capacity, what will happen? Will it overflow? No. So do you know the two things to find out already? Yes, like volume of water and the capacity, you know. These are the two things to find out. Okay, tell me how to find the volume of the water. Good. Good. Very good. So 40, 90, 30, 108, 000. So this is in cubic centimeters. What about the capacity of the cube?
45 times 45 times 45.
Very good. 45. So in other words, it is 45 cube. We can simplify all this to become 45 cube. And we get 91125 cubic centimeters. Okay, we've got the capacity and the volume already. So how will overflow or not?
No. Yes.
Why?
Because the volume of the water is
Excellent, very good. So this is the sign that we will use. Watch, this is less than. You can choose to follow me, shortcut. Sorry, your iPad. You can choose to follow me, shortcut. Put a less than sign. Less than 108,000. And you answer. It will overflow. You can choose to write it this way. Okay, this is the shortcut that I'm using. Thank you. You can go back. Alternatively, if you don't want to learn the mathematical symbol, although you must learn, if you choose to be stubborn, I don't want to write that. I don't know how to use the inequality sign. I want to use words. Okay, Ken, you write it down in words, which is less than 108,000 cubic centimeter. So then it will overflow. So you choose that. You want to write so many words, or you want to write one mathematical symbol. They both are all right. But I have a preference, which is to just use the mathematical symbol. Any questions? Last week finish writing already? Next. Okay, simple questions over here. Who wants to try? Very simple. Very, very simple. Square of 11. Yeah, okay, come. What's the square of 11? What is the square of 11? 11 square lah. See, square of 11. 11 square. No lah, write down the value 1 to 1. Square of 11. This is what it means. What about the square root of 25? Yan Rui? Square root of 25. What should I write? Square root of 25? Come quick. What should I write? Hey, I see the answer a lot of time already. Square root of 25. What should I write? I said this so many times already. Square root of 25. What should I write? Yeah, right. Square root of what? 25. And what is the answer? You come to maths lesson without calculator. Jin Xian, what is the value? Yes. Nazrin, what is the cube of 6? Okay, so you write 6 to the power of 3, which we get 216. Very good. Next, cube root 512. What do I write? Indra? Okay, watch how I'm writing the cube root. Look at this little 3 over here. It is a little 3, literally a small 3. And what do we have? 8. That's all for your homework question. And now,